Hello, everyone. My name is George Kobar, and I'm a community advocate for Elastic. And thanks for coming to my session, which is Observability for Kubernetes, fast food for containers on the move. So I'll be in chat today, so if you have any questions or comments that you'd like to bring up, please ask away. And if you'd like to connect or network after this presentation, I'm on LinkedIn or Twitter at George Kobar. And I'd love to hear different feedback and thoughts that you may have. So, about 15 years ago or so, I was a system administrator, specifically for Microsoft Exchange, and ran a BES server. And I remember the days of getting a phone call at night, that a executive wasn't receiving their email. And, of course, groggily getting to my computer and trying to assess what's going on. Either logging through an RDP session or, if that was down, try to go to a remote KVM or some type of DRAC, and get to the system and see what was going on. And of course, when I got in, take a look at any of the metrics, like through Task Manager or logs, see what I could find for this, what was going on. And, whether it be, doing a tail dash F or top or within Windows, the process was the same. And with a lot of these monolithic applications today, doing this type of troubleshooting or process was easy because all the services were just on that one host or virtual machine. Well, kind of speed up today when we're doing monitoring of these microservices containers on Kubernetes, and having this distributed systems, troubleshooting issues or even observing systems becomes, I wouldn't say difficult, almost impossible to do. The amount of scale and trying to locate the issue is a real issue. And if you consider the life cycle of some of these containers, according to SysDig from this 2019 report, that almost 40% or over 40% of all containers in terms of their life cycle only less than 5 minutes. So if you're trying to troubleshoot a performance problem or some issue that happens to be intermittent, it just becomes that much more difficult if the container is gone. And if you also consider maybe your coworker said, hey, you know what? It's the middle of the night. Let's just go ahead and redeploy, and hopefully that will resolve the issue. All of that forensic evidence or that history that you have is magic or is gone. You have to wait until the issue happens again before you see anything. So I think that's one of the challenges over and above just the scale of these large microservice architectures. And of course you could send all this data, as soon as the container comes up, send this data to, let's say, a data lake, or, I'm being a little tongue-in-cheek here and saying, hey, send everything to syslog data, right? And this is me looking through error messages for a 7.78 gig log file, right? Obviously, hopefully this is not your organization, and maybe you have some tools in place that are around this, but I mean, this is ultimately a search problem. When you're responsible for a business critical application, like for me with Exchange or at the time, a BES server, or for you when you're looking at the business critical applications, trying to get the answers for what's wrong is really a search problem. It's searching for answers, searching for, is it infrastructure related, searching where the breakdown of the issue is. And luckily, Elastic is a search company. And we'll kind of go into more in details of the open source technology that really provides this. But if you look at what is search today, it's really omnipresent in all of our lives. If you look at an application on your phone or on a website, if it has a search box on an app, more than likely it's Elasticsearch behind the scenes. Elasticsearch is a search engine. You could put lots of different data into Elasticsearch and be able to search for it near real time as it's coming in, and search very quickly. That kind of gives us the unique use cases of being, for logging metrics and observability, to security events, to even searching for e-commerce data, right? It's omnipresent in in our everyday lives, and a search is when you think about search, Elastic is a search company. So kind of a step back and talk more about the Kubernetes ecosystem here. But looking through the documentation, starting a few years back and working with Kubernetes, I wanted to get a good idea of kind of what are some of the second day operation things that you would do when you set up a cluster. And if you look at they're very unopinionated on like backend services, or what it comprises of the logging or collection backend. And if you look at just the CNCF landscape here, I know this is kind of a large, I'll move my window here. This is kind of a large landscape and what this would look like. But if we're really just focusing on the observability or the analysis part, really the amount of graduated projects and or open source and paid products for observability, there's quite a few still for you to choose. And it's funny. I just went to a meetup earlier today, and they were talking about these are just some of the technology radar for observability as of September 2020. So we can take a look at some of the open telemetry for assessing trial or adoption. So even when you're looking at this landscape, having a good visibility into where they're at in how mature they are into this process is huge. Now, I know when we talk about observability, you'll probably hear the most common use cases or the common things that you should collect to have a really good observability strategy is application tracing, metrics, and logs. And really, a lot of people say that that's kind of the three pillars for observability. I think there's one more that's really critically important here, and I'll get to that just a second. But if you start to match these pillars of using Jaeger, for example, for application, for traces, Prometheus for metrics, and FluentD for logs, for log analysis, and then visualizing data through Kibana and Grafana. These are some of the tools that have graduated, and they recommend for you to get that view. Well, and while those technologies in itself are great, it kind of it gives you a little heartache in some of these areas, right? So these are just different tools, which means they're different user interfaces, and you're kind of building up these different silos within these teams, or teams using different tools for the jobs that they have to perform. So you're still, if you want to look at traces and you determine, the application, there's nothing wrong with the traces here. Maybe we should shift gears and look at maybe some of the metrics. You might have to go to an entirely different team that might have an entirely different tool, or in this case, just a different UI. So the troubleshooting or really reducing the amount of impact or trying to find what's wrong with this application is, it takes a lot longer, right? And this still becomes a search problem. You're still looking for this data in different locations that could be held or responsible by different teams. Well, one thing that you could do, my apologies, I'll stop moving my my head in just a second. But some of these tools, for example, Jaeger, Prometheus, and FluentD, you can import that data into Elasticsearch. And in Elasticsearch, then you can visualize that data. And that's great because you're really giving this single source of truth with just as the data. But I like to suggest that even this is still, kind of an issue, right? We're getting to a closer spot here, but you still have a separate screen for traces or metrics or log information, right? And that's kind of what I mean about this term Observability. By the way, this is my only PowerPoint trick, right? Anyway. But elastic schema, or having a common schema across all of the different data sources, really should be a part of your observability strategy. And what is the elastic common schema? Well, elastic common schema is an open source project through Elastic. And what we're doing here is we're providing a common language across these multiple data sources, and giving you that schema where if you introduce a new data set or a new data structure, that you'll have a schema that you can be able to ingest and search across. And that's kind of what I think really observability is the greatness of a sandwich of this observability. Is having these three components of APM metrics and logs, but also a common schema that you could search across. I guess another way of TLDR on this is it's a lot like the universal translator in Star Trek. You have many different alien races, so many different languages, even across our globe on Earth, there's so many different languages. But it wouldn't be useful if someone could talk to you in their native language and you could hear exactly what they're talking about. It's the same type of mentality here. It doesn't matter what the data sources or the things that you bring, as a part of your observability. Having a common schema and for you to correlate some of that data is very powerful. As an example here, let's take a look at this log message here. This was just grabbed from, I think this was from an Apache web server or some request, right? But if we apply this Elastic common schema or just a common schema, we could see that we're taking the common fields within this log message, like timestamp, request method, what was the response status code, and then we're also having a value. Now I can take a different web message or a web server log message and apply these different fields, the schema to it, and I may have some empty fields here and there, but the data set is the same. The data is different, but the schema, the organization of the data is the same. And how that could be powerful is on the left-hand side, we have like an example of log messages from Kubernetes. And using the common schema, we could see that, hey, we have this UID for this Kubernetes pod. And on the right-hand side, we have metric data. Well, the thing is, when you receive logs and metric data, they're both referencing the pod UID. And those are some things that you can correlate. You can, when you are troubleshooting an application or something within your Kubernetes deployment, you can go from traces, knowing that maybe what containers that this service is on, to understanding where those containers reside on which pod, and maybe what host. So you could get a drill down of, hey, is it a host issue, or is it a pod issue, or a container issue, or maybe some coding issue. And as you see through the demo I'll show you here in a few minutes, having that workflow and going through and having that unified piece of connecting field data across many data sets is extremely powerful. And that's kind of really the integration and the thing that you should have as a part of your observability strategy. And of course, you could think about, hey, maybe what are some other things that you can really string across, maybe like time. Well, the problem with time is, as we all know, it's great that if all machines are on the same time zone, right? I've speaking about the nirvana that everything could be across UTC, right? Wouldn't it be great if everything's just one time zone or UTC? But of course, that just never happens, unfortunately. Or even the messages that you would receive, they might come in at a different time because the system's overloaded, or there's so many different aspects where time could be inconsistent. So that's why having something just like this, I'm not saying just a Kubernetes pod UID is the only thing that we're really matching up here. It very well could be the service name or a label or a tag or asset. The foundation of this is having a common schema that you create either by you or using our schema to really get a foothold of workflows and relationships in these multiple different data sources. And again, it doesn't have to be just logs or metrics. That was just an example. Very well could be, security events, could be network data, traces, geospatial telemetry data. It very well could be business KPI data. It could be that you want to combine some of your observability and your security data, and you can see some correlations there. Maybe if you're getting some type of exploitation on your application, and you're seeing a high amounts of CPU, well, then obviously there's a problem with an exploit. You have to resolve that from the development standpoint, but you also can study it from a security standpoint. So a lot of these data pieces, like a Venn diagram, they really overlap with each other, and by adding those data pieces together can really help you enrich and understand what's going on from a higher level. So when you look at this, from a same tool or a same UI and same teams, I think our Elastic solution for observability really provides that with that common schema. So if you have another team, let's say the application team and infrastructure team, if they're trying to troubleshoot, they may have their own separate dashboard, but it's the same user interface. You could easily share this dashboard with someone else. If you're the developers and saying, hey, our application that's having troubles, we don't see any issues with the traces. But I happen to look at the metrics and I'm seeing this issue. Can you take a look at this with me? Or, involve the metric team and say, hey, can you take a look at this? This is kind of what's seen with tracing. So you really break down a lot of the silos or the need for having many different tools, and everyone's able to collaborate together. And that really drives down the mean for resolving these issues. And of course, that translates to saving money on downtime, right? So having the same tools, same UI, same teams is really powerful. And that's something they'll see within the demonstration a little later. And a lot of this is possible through the open source Elastic Stack, or you might have heard it as the ELK stack, right? So you have this ingest layer, which is beats and Logstash, which I'll talk a little bit more about beats because that has a good framework into the Elastic Common Schema. But all that data is ingested, or using these methods ingest the data into Elasticsearch. And Elasticsearch is that data analytics layer. It's the heart of the stack. That's the search engine. And as much data you could put into Elasticsearch, you're able to search on high cardinality fields, different data sources, different data types, right? I mean, it's a very powerful search engine. And of course, using Kibana to be able to visualize that data and manage a stack is also equally as important. There's so much data that's available to everyone. Even teams have a difficult time going through every single line of metrics or logs. So visualizing that data and using anomaly detection really can help expedite some of these issues. And alerting based off of, hey, we see anomaly and that's outside of what we see as normal. Let's go ahead and alert the folks that are in charge. Now in 7.9, we introduced something called the Elastic Agent. And if you're familiar with our architecture, I'll go ahead and go back here. I'm talking about the beats layer here. This is a lightweight data shipper that you install on an endpoint, such as a host for your Kubernetes pods, or some type of infrastructure like a virtual machine, or any type of infrastructure, so to speak. Well, what we're doing is before you had to install separate beats. You had installed maybe a metric beat to get the metric information, or file beat to get logs, or packet beat to get a lot of network information. Well, what we're doing is we're creating just one Elastic agent, or one beat that has all these modules included. And that really simplifies what needs to be installed on the endpoint. And this agent, this lightweight data shipper is extremely lightweight. It doesn't impact the performance, CPU or memory of that endpoint. And it also is just responsible for collecting this data and shipping into Elasticsearch. So we think about the infrastructure. If you want to get the data from CPU or kernel, if you're on a host or a virtual machine, or if it's within a cloud, if you're using AWS or GCP, grabbing some of that metric data that's exposed and that's on the Elastic Agent and shipping into Elasticsearch. Same true for logs. You want to get maybe kernel logs, system logs, anything with infrastructure related. Obviously, as a part of that observability framework, you want to be able to ship that data, from the lightweight agent into Elasticsearch. And we kind of talk about, some of the challenges of having applications in Kubernetes is, when one container is somehow killed or brought down or some issue, is how do I still know, what service resides on a different location? So if you have, for example, one pod happens to go down, or one full node goes down, we know that those containers obviously will be, brought up, the microservices will brought up onto a new pod, into a new node. Well, how from a standpoint, from an observing standpoint, do I know that those containers are being moved? How am I able to track that? How am I able to observe that and really kind of troubleshoot exactly what happened? Well, as a part of this Elastic Agent and in our beats, this is no new. There's nothing that's new about this. There's this auto discovery within inside the configuration, so you can configure this discovery anytime. For example, on Docker, that you see a container needs to start or stop, you can bring, that type of event will be recorded, and then it will be able to report on host, port, image ID, and maybe some labels. And the same is true for auto discovery on Kubernetes. So we have a Kubernetes provider that goes through and looks at container ID, namespace, node name, labels, UIDs. So what we're doing is anytime Kubernetes nodes, pods, services either start, are updated, or stop, we're going to record that information and automatically start to have that together. With that comma schema, we're able to string together, let's say, service name with container within pod ID within node. So we're really kind of stringing this together, and you'll see with the demonstration, I could easily go into logs of one pod, maybe into container metrics, and then really look at the traces for that particular container. It's a nice workflow having all of that together. That's powered by that Elastic Common Schema, that integration. So, and if, for the future, and this is kind of a future state, the Elastic Agent will also do traces. So your application tracing. So today we still do this as a separate container. It's sent to a application performance monitoring server, and then it's shipped to Elasticsearch, right? But this with a future state, so 7.9 and later, you can grab the traces from this Elastic Agent or this beat. And you'll be able to gather traces from Go, Java, Node.js, Python. And we know a lot of environments are heterogeneous, which will go into the demo. So it's really great that we're able to support so many different languages and look at the traces. And again, looking at all this data, from the infrastructure to the Kubernetes to applications, we're sending all this data to Elastic Agent, and then shipping this off, applying this comma schema at the Elasticsearch layer, and then into Elasticsearch for this to be able to view through Kibana. So not only is the Elastic Agent something we just recently announced, really helps simplifying the installation and ingest of all that data, but the comma schema makes this a lot easier for you to search across the multiple data types. So with that, let me go ahead and jump into a demonstration here. And what we're going to do is really to showcase kind of that workflow of having that single source of truth, that data for all these different traces, metrics, and logs. That single source of truth, which is just the data, really helps break down those barriers. And hopefully you'll be able to see that here with this demo. So in this demo, we're going to show you how the Elastic Observability solution can really address a lot of challenges for some of the operations and reliability teams on observing applications using a modern application architecture, such as containers or Kubernetes or serverless, as an example. A lot of these operations and reliability teams are really tasked for delivering a superior digital experience. And if there's service interruptions or performance issues, then that really translates to loss of revenue. So, having a solution like Elastic Observability, and just what Nerdeep had shown, we could see that having the data in one single source, or the data is the source of truth, really helps out a lot of different teams across operations, the business KPIs, metrics. Any of these groups are really looking at these silos of data. Having a single source of truth for data really helps out with these teams and these modern application architectures. So for the purpose of this demo, there is this company that we've, quote unquote, created called Hipster Incorporated. And Hipster has this e-commerce store that we could see right now. And it's a fully functional e-commerce platform. So I can, let's say I wanted to buy a vintage camera lens, I could do so, add to cart, and of course, purchase through there. And Hipster Incorporated, this company that we've created, they're heavily relying on a digital experience. They don't have any storefronts or brick and mortar storefronts. They just have this e-commerce method of transactions. So the operations teams have to ensure that if there is an outage, that it's very small, or to avoid outages altogether. And they've chosen Elastic's observability solution really to showcase this. And of course, just like most companies with a digital experience or some type of digital storefront, if they have any type of outage or issues, they're losing revenue. And we've kind of seen that on time and time and again, how companies lose millions of dollars due to outages. So really, mean to resolve is a huge issue, or evolving or avoiding issues altogether. And for this particular e-commerce application, let me go ahead and show you the architecture, because I think it's really important to show what's going on behind the scenes. So this hipster online app or store app was really built on cloud-native technology architecture. So it uses a 10-tier microservices architecture that's built with a variety of programming languages, which includes Go, C#, Java, Node.js, and Python. And they're also using Redis for in-memory data caching. And so all of this happens to be running on a Kubernetes-based container platform that's running within GCP. So it's a modern architecture that really gives this demo company, this hipster company, the flexibility to be able to scale up and scale down, really adhere to the business needs. So one of the reasons why they chose Elastic Observability is because not only does our solution can handle the broad range of cloud-native technologies like GCP and Kubernetes, but it also can handle the monitoring of a lot of these heterogeneous programming language environments. So we commonly hear, hey, we're a .NET shop or a Java or a Python shop. But even because if you're using one particular language doesn't mean that you don't have pieces and other code that's a part of this architecture that's in different languages. And that's why the power of having the source of truth, the data, really can be powerful here. And so the business also uses, or the operations team uses a specific dashboard to kind of give this representation here. So it's, we can see monitoring of service, response times, apps served, breaking down by logs, metrics, and application performance. But I've also, in something I'll showcase a little bit later, is also a business KPI, CPU memory, and SLA. How much, is there something that we can learn from the business side of all of this data? But Hipster Incorporated uses this dashboard to give them that single pane of glass. So with that single source of truth, that data, and we're also using that, a unified common schema, or the Elastic common schema, to really help track and maintain SLAs. So now that we've kind of gone through the architecture and gone through some of the platform pieces, actually, one thing I do want to go back real quick on the architecture. So we have a lot of our application performance monitoring agents that are installed with the ad service, front-end service, load generator. We also have FileBeat and MetricBeat that are collecting metrics and logs from the container, or from the source or the host, or from the host itself, and along with the application services. Now, that's kind of important to note, because all that data is being sent into Elasticsearch as that single data source that we have. So if we kind of look through the journey of this demo, I want to show you maybe an example of kind of how, as an operations team, is working with Hipster Incorporated to really root out and find issues using this observability platform. So alerting is really critical. Alerting is a really critical part of any type of operational workflow. An Elastic Observability solution really provides a powerful and flexible alerting framework, lets you be notified on changes or issues within the environment. And it integrates into popular collaboration ticket tools and anything that you can act on through these alerts through the existing operation workflows or processes. So to kind of showcase that, we got an alert from Slack that there was, let me pull that up here, there's a high mean transaction duration for the Advent service. Now, we could see that there's a critical anomaly and the score was 81, right? So what is this alert really kind of telling us? Well, there was an anomaly detected by Elastic's machine learning job that was triggered for this particular alert. So Elastic Machine learning is an unsupervised technique to model business trends and automatically detect deviation from this normal behavior. So if you actually click on this alert here, it'll take us right to a service map. And the service map is really great because let's say you're not really familiar with this particular application. Maybe you just joined. This is, or maybe you're really looking through a complex application. The service map really gives a nice little viewpoint of how all these services are really integrated. So we could see that, the advent service, which was that sent the anomaly, is circled under red. But we also can see that the front end service is red. So the advent service is written in Java. The front end's written in Go. So not only gives you the kind of languages, but it gives you a nice flow of that services. So if I pull up our map here, we can kind of see the advent service, how that's all written down. But actually, the mapping service is the actual service itself. So let's go ahead and go into the advent service and take a look what's going on. This gives you a nice little summary of the anomaly detection, transaction, CPU memory, so forth. But let's go ahead and view the anomaly itself. So this will actually take us to the screen, our machine learning screen and our single metric viewer. So when we say that, what's the normal behavior, really the high and low, we can kind of see how the unsupervised learning can detect this, right? There are a couple peaks, a little higher and lower, but transactions, and this is what the metric we're looking at is high mean transaction. We can see a couple times that's actually kind of crept up, right? And as operations, people like to notate if they are addressing an issue. So we see that this is notated by another operator as they put this at 5 in the morning. I know. So it's probably something in the middle of the night they got alerted on, and probably restarted the service. We can take a look at more into that. But it looks like later on, someone else went ahead and redid a redeploy of that new environment. They actually put an annotation here as new deployment. And it looks like that new deployment really didn't have any positive effect, because later on, and this is what we just got notified on, is that there's an issue here of anomaly score of 81. A higher anomaly outside of what the unsupervised learning shows as normal, right? So it's really outside those bounds. So one thing we can also do is take a look at the actual anomaly. So if we expand that out and kind of look at, what's the high mean, what's the actual, what's the typical, and what's the job ID. So I think that's great. But let's go ahead and look at the actions, and let's actually take a look at the service that's responsible or showing this, and that should be the advent service. So if I go into APM, we can kind of take a look at the transactions or the spans for this advent service that we're monitoring. And we can kind of see some spikes here in some of the transaction durations, which was, if we look, we can see those 3 different spikes within our anomaly view. This actually shows relatively the same thing. And we also can see a correlation between maybe requests per minute. So we know that anytime that we restarted the service, there's going to be no requests. But it looks like this is definitely negatively affecting us. And if we can take a look here at the name of this service, it looks like we're trying to get ads. And if I select this service itself, let's go ahead and take a look at the actual span. Now, most of the spans over duration period, you could see that most of the transactions are over between 100 and 200 milliseconds, or even 200 to 300 milliseconds. That's mostly all of it. Now, if you're not really familiar with a span, you can actually look at successful spans, and then also look at right next to each other a span that didn't work so well. If we look at the duration here, we can see there's 2 requests that came up as 1,600 and 1,700 milliseconds. And if I select into that transaction, then we can kind of start seeing, why was this good versus bad. I'm gonna go ahead and expand out the full trace for the transaction that was bad, and take a look at it. Now, I don't see any particular issues going on with the span itself. I'm going to go ahead and go back here just a little bit and see if, on this particular transaction, we're seeing there's an error here. So if we actually click on the error, this will give us more information about, it actually looks like this is coming in from the front end. So the front end received this request to the advent service, and it looks like the error stack trace is content deadline exceeded. So the the front end service was trying to contact the ad service, but there was a deadline exceeded. So there might be some issues here. I don't see anything within the traces for any particular issues with the code. But let's say if there was a problem and there was some type of error or something within the code that was causing performance or issues there, you can actually copy, all of these, library frames, things that are associated with it, copy and paste this and send this off to your development team for further investigation. But I don't see really any evidence of what's going on here from an application perspective. It looks like we're just getting a timeout. Unsure if it's really a code. It could very well be something underlying like the infrastructure. So we can take a look at some of the metrics. But just in case here, what I'm going to do is I'm going to close this window out. And I'm going to come back to our service here. And I'm going to go ahead and take a look at our dashboard, see if there's any other evidence we can see here. And actually, I think that this dashboard is going to show us the overview APM piece. It is. What I'm looking for, actually, I'm going to go back. Now, we know that we've been looking at the advent service, so let's go ahead and actually jump to the front-end service. So I'm going to come back to our service map, which is just a tab that was automatically opened. I'm going to go ahead and open our front-end service, and I'm going to take a look at that anomaly score as well. We know that the front end was waiting on the advent service. There's a timeout. There's something going on here. And we can kind of see that the high mean transaction is also high, which we kind of knew about. And if we go ahead and go to actions here, let's go to, we can see the transaction and the means for all this front end services. Let's go ahead and take a look at some other views that we could be looking at. So we know it might not be something with a code, but let's maybe see if we could try to find any of the other issues with, let's say, within the logs. So under observability, if we just go to the log screen, then we can see if there's any type of logs that would maybe showcase any type of issue within the platform. Now, one thing you could do is you could also narrow down the host, for example. Like if we know what host this particular application resides on, or maybe a particular container. But one way you can also do this is stream the logs live. So this would be just like going to a tail-f on that particular application or on that particular container or host. And if you do that tail-f, you'll be able to live, if the issue is happening at that time, live stream some of the logs. Now, in the interest of time, let's just say we didn't find anything with the logs. As a matter of fact, a better view is if we look at some of the single metric view and we take a look at the Anomaly Explorer. This will kind of give us a nice little viewpoint of different anomalies that have happened. And if we actually go to expand out this little anomaly detection, we can actually take a look at these different dashboards that will show this, or our APM service. And we can create different new dashboards using some of this data. But if we actually look at the view series of this data, then we can kind of get a similar view of these transactions going over. And actually, this is very similar to what we were looking before. Now, if I come back over to, instead of logs, let's investigate maybe if this was an issue at the metric level or under metrics. So let's go ahead and go back over to our screen, and under observability, let's jump into metrics. And from here, we should be able to see the Kubernetes pods and single VMs. We'll be able to expand or look at these individual. And right away, we kind of see, well, it looks like there's a couple hosts that might be at 91% usage. But instead of showing hosts, let's go actually look at the containers themselves. And then the metric, we'll look at the CPU and memory of all of these containers. Now we see a couple containers here that look like that's, 384% CPU. And we can actually jump right into this container and look at logs or look at the container APM traces. So it looks like from this particular issue here, it very well could be a potential issue with maybe one of the containers. If it's using far more CPU than it's intended, 384%. And if we also maybe we'll take a look at some memory usage, we can also see that looking at the container view, there might be some memory leak or something else that we can find. But again, if we look at from the Advent service or the front end service where those services are located, you can actually look at the specific container and its metrics and its logs and see if there is any correlation there. So that's a good way of, again, I didn't jump from tool to tool or from application to application to really look at this data. I'm just using some of the workflows, and you can build your own type of workflows for investigation of what could be happening. And that single viewpoint, either through a dashboard or jumping through some of these, it really is helpful for reducing the mean time for resolution on some of these issues. But one of the things that I really wanted to also talk about is really what's the value behind having a dashboard that's really similar to this. I mean, it's great for operations teams, and we all know if we resolve issues quicker, that the downtime is not going to impact the business as much, right? I mean, that's a great value to see. All right, well, hopefully by you seeing that demo, you really can help out visualize the workflows. I was able to jump into metrics and logs and traces by kind of doing this investigation. And all that's really bound together by that schema. And also having that data all residing in one area, which is extremely helpful. Well, hopefully you're able to gain some insights from this presentation. I'm really looking forward to participating in the rest of the J4K conference. Now, if you have any questions for me or you're wanting to network, you can always reach out to me on LinkedIn at George Kobar or on Twitter. I'm always happy to make new acquaintances. Well, again, thank you for your time. I really appreciate it, and have a great day.